In this video, we're going to look at another example of integrating using partial fractions where we have to apply long division first. Here we have integral x cubed divided by x minus 2 times x minus 3 dx. If you look at the numerator, the degree of the numerator is 3 because x cubed is a polynomial of degree 3. If you look at the denominator, that's x minus 2 times x minus 3. If you were to expand that, the leading term would be x squared. That means the degree of denominator is 2. And since 3 is bigger than 2, we have to apply long division first. So we have x cubed divided by x minus 2 times x minus 3. Let's multiply out the linear factors in the bottom. So we have x squared minus 3x minus 2x is negative 5x plus 6. And we have x cubed in the numerator. Now let's do the long division. So we have x cubed divided by x squared minus 5x plus 6. Now x squared goes into x cubed how many times? X times. Now distribute. X times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 6 is 6x. Let's put some fillers in here. It will make our job easier. 0x squared, 0x. Now it's very important that you put a minus and bracket here. This is the most common mistake, not distributing the minus sign. X cubed minus x cubed is 0. 0x squared minus 5x squared is 5x squared. 0x minus 6x is minus 6x. Now how many times does x squared go into 5x squared? Well, that goes in 5 times. Look at 5x squared minus 25x plus 30. Subtract, distribute a negative. 5x squared minus 5x squared is 0. Minus 6x minus 25x, that's minus 6x plus 25x is 19x. Let's put a 0 here as a filler. And 0 minus 30 is minus 30. This is a remainder. And this here is a quotient. All right, so what we have is x cubed divided by x squared minus 5x plus 6 is equal to x plus 5 plus 19x minus 30 divided by x squared minus 5x plus 6. So essentially it's the quotient plus remainder divided by denominator. All right, so what we have is let's now integrate both sides. We have integral x cubed divided by x squared minus 5x plus 6 dx. That's integral x plus 5 plus 19x minus 30 divided by x squared minus 5x plus 6 dx. Now we're going to split up the integrals. So what we have is integral x plus 5 dx plus integral 19x minus 30 divided by x squared minus 5x plus 6 dx. Now let's integrate the easy part. What's the integral of x? That's going to be x squared over 2, reversing the power rule. What's the integral of 5? That's going to be 5x plus the integral of 19x minus 30 divided by x squared minus 5x plus 6. So we're going to apply the partial fraction decomposition to the integral. 19x minus 30 divided by x squared minus 5x plus 6 is the integrand. That's going to be equal to 19x minus 30. Let's factorize the denominator as a product of linear factors. That's going to be x minus 3 times x minus 2. And now let's apply partial fraction decomposition. This will be a divided by x minus 3 plus b divided by x minus 2. All right, so we're going to multiply both sides by x minus 3 times x minus 2 to clear out the fractions. On the left-hand side, we're going to get 19x minus 30. On the right-hand side, we'll get a times x minus 2 plus b times x minus 3. Now, the most efficient approach here is to just plug in numbers to solve for a and b. So let's plug in x equals 2. If we plug in x equals 2, what do we get? We get 19 times 2, that's going to be 38, minus 30, that's going to be 8, is equal to a times 2 minus 2 is 0, plus b times 2 minus 3 is negative 1. That's 8 is equal to negative b divided by minus 1, and we get b is equal to minus 8. Now let's plug in x equals 3. 3 times 19, that's going to be 57, minus 30, that will give us 27. A times 3 minus 2 is 1, plus b times 3 minus 3 is 0. That gives us a is equal to 27. So we've done the partial fraction decomposition. 19x minus 30 divided by x squared minus 5x plus 6. We factorize the denominator, 19x minus 30, divided by x minus 3 times x minus 2, and that's equal to a over x minus 3 plus b over x minus 2. That's the pattern of the partial fraction decomposition. And we found a and b. A is 27 divided by x minus 3, and b is equal to minus 8. Minus 8 divided by x minus 2. So just to review, we have x cubed divided by x squared minus 5x plus 6 dx. We did long division, and we got x plus 5 plus 19x minus 30 divided by x squared minus 5x plus 6. And we integrated the easy part. X plus 5 got integrated to be x squared divided by 2 plus 5x. And then we have this integral, and we've applied the partial fraction decomposition to the integrand. All right. So now we have x squared over 2 plus 5x plus the integral of 27 divided by x minus 3 minus 8 divided by x minus 2. All right, so let's carry forward the solved integrals. We have x squared over 2 plus 5x. And now let's split up the integrals. Plus integral 27 divided by x minus 3 dx minus integral 8 divided by x minus 2 dx. That gives us x squared over 2 plus 5x. Now 27 is a constant. It passes through the integral, so we can write 27 times the integral 1 over x minus 3 dx minus 8, because 8 is a constant, passes through the integral, 1 over x minus 2 dx. Now, each of these integrals can be easily solved by the method of U substitution. So we'll let u be equal to x minus 3, and du is equal to dx. Similarly, for the second integral, we'll let u be equal to x minus 2, and du, the derivative, will be dx. So the result is x squared over 2 plus 5x plus 27 times integral of 1 over x minus 3. That's going to be log of absolute value of x minus 3 minus 8 times log of absolute value of x minus 2 plus c. This is the answer. All right, thanks.